Hey guys, Professor Calculus is here. Today in this video, we're gonna see how we should solve this integral. Before that, make sure to like and subscribe, as it is free and you can always change your mind later. So, first of all, I'm gonna go ahead and define the variable t equals tan x, and if I differentiate both sides with respect to it, I'm gonna get dt equals secant squared x dx, and we're gonna use the identity of secant squared x equals to 1 plus tan squared x. So if I replace it here, I'm going to get dt equals 1 plus tan squared x dx. And since t equals tan x, my dt is going to be 1 plus t squared dx. Therefore, dx is dt divided by 1 plus t squared. And for the boundaries of this integral, when t equals pi over 4, tan of pi over 4 is 1. Therefore, my integral would be from 0 to 1 of the ln of t over 1 plus t squared dt. Now here, I'm going to use the integration by parts. It says that if I have a function u dv, I can write it as uv minus v du. Let's define our u and dv here. My u is ln t. My dv is 1 plus t, 1 over 1 plus t squared dt. My v therefore is arc tan of t. My I therefore, the integral would be arc tan of t ln of t from 0 to 1 minus the integral from 0 to 1 of my du is 1 over t dt minus arc tan of t over t dt. And if I apply the boundaries here, I'm going to get arc tan of 1 ln of 1 minus arc tan of 0 ln 0 minus the integral from 0 to 1 of arc tan of t over t dt, and arc ln of 1 is 0, arc tan of 0 is 0. Thus my I integral is just negative from 0 to 1 of arc tan of t over t dt. Now we're gonna from here use the series of arc tan of x, which is arc tan of t, which is the infinite sum from 0 to infinity, and it is equal to negative 1 to the n t to the 2n plus 1 over 2n plus 1. So if I replace it here, the series for arc tan, my I is going to be negative the integral from 0 to 1, the n from equals 0 to infinity, negative 1 to the n t to the 2n plus 1 over 2n plus 1 over t dt. So these are going to come away of this integral because there are constants from 0 to infinity of negative 1 to the n over 2n plus 1 over 2n plus 1 from 0 to 1 of t to 2n plus 1 over t dt. And according to the power rule, this is going to become t to the 2n dt, and with the power rule of the integration, I can write it as t to the 2n plus 1 over 2n plus 1, the integral from 0 to 1, and that is going to give me 1 to the 2n plus 1, which is 1 to any power is 1, and 0 to any power is also 1. This is going to become negative 1 to the n over 2n plus 1 squared. And this is actually Catalan's constant. So the Catalan constant is defined as the infinite sum from n equals 0 to infinity of negative 1 to the n over 2n plus 1 squared. And negative g is just the negative of this infinite sum here. Therefore, the integral from 0 to pi over 4 of ln of tan x dx is negative g, the Catalan's constant. Thank you for watching this video. Please like and subscribe, and I'll see you next video.